In this video, we are going to discuss authorization in NestJs. We are going to see how we can implement roles and permissions and protect our routes so that only users with a specific set of permissions are able to access them. So I asked you guys which type of authorization video you'd like to see, role-based, permission-based, or a combination of both. So you guys voted for a combination of both. We are going to have some dynamic roles attached to a user, and those roles are going to have some predefined set of permissions. So we're going to build authorization on top of this application. So we had two different videos before where we discussed authentication. This is the same code base. I'm just going to go quickly over it so you guys know what we already have. So if we take a look here, we can see that we have an auth module where we have a controller with some APIs such as sign up, log in, refresh token, change password, and so on. We also have some schemas such as the user schema where we have name, email, password, and in this video we're going to be adding the role and so on. And we have some DTOs to validate the payload of the request being made. And finally, we also had an authentication guard because after logging in, of course, we are providing a token to our user. And this authentication guard was used to protect our routes and verify that the user making a request is actually logged in. So we were using the JWT service to verify the validity of a token. So in this video, we are going to create a roles module with the necessary methods that are needed. We are going to create a custom permissions decorator to specify which permissions should be used for each route. And finally, we are going to create an authorization guard to compare the user permissions with the required route permissions and either give access or throw an error. So I went ahead and ran this command, nest generate resource roles, which created this controllers, module, and service files for us. And then I went ahead and created a schemas folder with a role.schema.ts, which is empty now, just to follow the convention that we followed in the previous episode. Now let's think of a role. First of all, of course, a role is going to have a name. It's going to have a unique ID, which is going to be the Mongo ID. And here we need to specify some permissions. So there are a few different options that we can follow to store our permissions in the database, each having their own advantages and disadvantages. I wrote here three different options, so let's discuss the advantages and disadvantages of each. If you take a look at option 1, permissions is basically an array of strings, so we just have strings here. And if you take a look at our strings, they all have the same pattern. We have the section or the resource name, for example user, followed by a colon, and then followed by the action that we can perform. For example, create, delete, and update. So a user with this permission set, for example, can create a user, delete a product, and update a user. As you can see, it's pretty simple. It's just a simple array, so it's very easy to implement, and it's very easy to check for permissions. So if a route required, for example, this user create permission, all we have to do is just check if it is contained inside of this permissions array. However, it does have some downsides. For example, as you can see, here we're not organizing the sections together, so we could have a user's create permission and then a product's delete. If we have a lot of permissions or we are trying to scale, this would become a bit messy. And in case we actually want to add some maybe options or configurations or information on specific sections, this would not really work. So for small application, it's fine, but if you're trying to scale, it's not the best solution. Now let's take a look at option 2. We also have a permissions array, but this time it's an array of objects where each object is basically a resource and some actions. The resource key is basically just the name of the resource, so for example, settings, or just like we saw previously, users or products, for example. And then the second key is actions. It's basically the object of different actions, okay? And here we are explicitly saying if each action is accessible or available for this user or not. So as you can see, the keys are read, create, update, and delete. And for each, we are specifying if this user can actually perform that action on this specific section. So to understand this better, a user with this permission set, okay, can actually perform a read operation since it's true on this settings resource. But since create is false, update is false, and delete is false, this user cannot perform create, update, delete on this settings resource. They can only read from it. This way, as you can see, is grouping the sections all together. So here, this object is all about the resource settings. It is organizable, okay? However, it is a bit more complex and a bit more difficult to actually compare. So if we have some permissions that are required for a route, in order for us to check if this user has those permissions, we need to make sure those keys, if they are true or not, and so on. And finally, option 3, which is my preference, honestly, we also have an array of objects. It's very similar to option 2. We also have a resource key with the resource, settings for example, and we also have an actions key, but this time action is not an object where every action is a key and then the value is true or false. Instead, actions is an array of strings where each element or each string inside of that array is basically the action that we can perform. So if you take a look here, this user with this set of permissions is able to read and create in the settings resource. They cannot delete or update because delete and update actions are not available in this actions array. This is a good way to organize our sections in case we need to scale or add some other things, other fields, maybe other information. We can do that while still not making it very complex like we did in option 2. So I think option 3 is a good way to scale, and we're going to go with option 3 in this video. So we previously said that we are going to have dynamic roles and predefined permissions. So of course we know our resources and actions beforehand, which is why I went ahead and created an enum for our action, for our CRUD operation. So for example, we have read, create, update, and delete. Of course, your system might have some more actions. For example, you might have publish, you might have unpublish, export, and so on, depending on your system. And we also created an enum for our resources or your sections for the application that you're building. For example, let's assume we have settings, products, and users. This way now, when we create our schema, we have well-defined constants for our actions and resources. That way we avoid actually saving or storing wrong permissions. So now we still need to create our schema for our role, and like we said, the permissions is going to be an array of resource and actions, where a resource is going to be the resource enum that we have created here, and actions is going to be an array of actions enum. That way we avoid having data issues later on. So I went ahead and created a normal mongoose schema in NestJs. So we have at schema, I created one for the permissions where we have a resource, like we said, is going to be an enum resource. It is going to be required. And then we did the same for actions, which is going to be an array of enum as well. And then we have created a role schema, which is going to have a name, which is also required. And then the permissions array, which is of type permission schema that we have created. I'd say everything is pretty straightforward so far. Let's go back to our to-dos. And now here we need to create some methods that we might need in our roles module. So I went ahead to roles module, and just like we normally do, I registered this mongoose schema here, just like we've already been doing in many videos. And in our controller, I went ahead and created a new route handler with an HTTP method of post, which is going to take a role payload, which is of type create role DTO. And here I just use some decorators from class validator to validate this payload and make sure all the inputs are correct. So we have a name, and then we have a list of permissions. I use validate nested and specify the type to be permissions. This way we are validating all the nested objects as well. And for permission, we specified that the resource and the actions should be there, and that resource is of type enum resource, and actions is an array of enum, which is the action enum that we have created here. And I used each true just to make sure that we are checking every single entry in this actions array, that it is valid. And I also used array unique so that we don't allow a user to pass the same action twice in a permission, because of course it would make no sense to send read twice inside of the actions array. So this is just some basic validation stuff. We've done a lot of videos on these, so I'm going to skip this part and now go ahead and simply create a method to create the role in our role service. Our role service is also pretty simple. I went ahead and injected the role model so that we can actually access the database and create a new role, fetch roles, and so on, just like we usually do. And I created one method called create role, which is going to take the role that we pass in, and then we're simply creating it. Of course, here you could, for example, add some validate uniqueness or unique names and so on. That way, for example, if you already have a role name of admin, you cannot create a new name or a new role with the same name. Of course, you can have validation here and so on. Now we might also need another method, for example, get role by ID, where we pass in the role and then we get the role ID and then we get the actual role. So we could say role ID and then simply return this dot role model dot get dot find by ID, and then here we can pass in the role ID. I don't think we're gonna need anything more than that. Now let's go to our auth module, and then in our schema, in the user schema, we need to add the role here. So I simply added the role ID, which is going to be of type Mongo ID. And now that we have our role module, let's go back to our tasks, okay? And now the next task is to actually create a permissions decorator so that we can specify what permissions are needed for what route. I went ahead and created a decorators folder in which we have one file called permissions.decorator.ts. This is where we're going to create our custom decorator. Creating a custom decorator is pretty simple. It's basically a function. Let's call this decorator permissions, for example. And then this function can take some parameters if needed. In our case, we need to pass in the permissions for the route, okay? So here, let's call this argument permissions, for example. And the type for the permissions is going to be this permission DTO right here. So basically a resource and then an array of actions. So let's use this as our type for the argument. And here we need to call set metadata. Okay, and set metadata takes a metadata key, which is a string, and then some value. So here, for example, we could call it anything. Let's call it, for example, permissions. And then the value would be the actual permissions that we pass to that route. So permissions. Now this might be a bit confusing if this is the first custom decorator that you create, but to make it easier, so since this is called permissions, we would use add permissions as our decorator. And since this function takes a permissions array here, it should be an array. Since it takes a permissions array, here we would need to pass in a permissions array. So it's an array of resource and actions, because this is the permission DTO that we have here. So these would be assigned as metadata, and to access this metadata value, we would need to get this via some key. And the key is going to be permissions, because here we said set metadata, permissions as the key, and then permissions arguments as the value. We're gonna see how we can use that on routes and then read those metadata from our authorization guard. So let's keep going. Let's try to use our custom permissions decorator on top of, let's say, this controller right here, app controller, in which we were also applying our authentication guard previously. So here, let's say permissions. This is our custom decorator that we just created. And if you take a look here, it takes an array of permissions, which is exactly what we set here. So here we need to pass in an array of objects, and then let's specify, for example, that this some protected route needs or is the resource of resource dot, again resource is an enum here, dot, let's say products, for example. So we can assume that this is our slash products controller, let's say, okay. And since this is a get API, let's assume that the actions needed to access this route would be, first of all, it's an array of actions, just like we said. And here we're just gonna have action.read. So the permissions needed to access this route would be a read action on the product's resource. So a user would need to have a role, a dynamic role that we will create in a bit, that actually has this permission available on it so that the user can actually access this route. Now, we still need to actually make the comparison and forbid or give access, because what this does so far is it only adds some metadata to this route. It doesn't actually have any logic to it. This just specifies the permission that should be there. So now what we would need to do is also add a second guard here, which is going to be an authorization guard, in which we are going to check the permissions of the user and compare it with this specific permission of this route. So let's see how we can do that. I went ahead and renamed the old auth guard to authentication guard, just so we know that this is taking care of authentication, so making sure that we have a valid token and so on. And then I went ahead and created a second guard, which is going to be our authorization guard, which is going to take care of the permissions needed and so on. So normally, whenever we are applying our guards, we are going to apply the authentication guard first. And as a reminder, in this authentication guard, after verifying that a token is valid, we are adding the user ID from the payload to this actual request object. So if you also remember in the last video, here we were able to also access the user ID by doing rec.userid. And this is available because we are applying the authentication guard on this controller, meaning we are also adding this user ID on the request from the token payload. Of course, if the token is valid, else we would throw unauthorized exception. So we are going to always assume that we are calling the authentication guard first, and then we are calling the authorization guard afterwards. So a user is indeed authenticated. So the first thing I did here in this case, I just got the request. I made sure that a user ID is valid on a request or is attached on the request object, else we will throw an error, something wrong happened. Maybe someone called this authorization guard without calling the authentication guard first. Also, I want to note one thing, that we don't have to make two separate guards. We could also add the permission checking logic inside of the authentication guard and just call it auth guard, for example. But just to make things cleaner and more organized, I prefer to personally create two different guards, one for authentication only and the second one for authorization. Now the next step is to actually find a way to read this permissions metadata inside of our authorization guard so that we know what permissions are actually required for the route so that we can make the comparison. Thankfully, NestJs gives us a helper class called Reflector that we can inject in our constructors. Let's go ahead and create a constructor here, and then we could say private reflector and import reflector from NestJs core. And if you take a look here at reflector, retrieves metadata for a specified key for a specified target. So the key here is the same key that I was talking about previously. So here in our permission decorator, if you remember, when we set this metadata, we said that we have a key for this metadata. So here, for example, this metadata key is the same one that is being mentioned here. It retrieves metadata for a specified key, and for a specified target, basically we're referring to either a controller or a route handler. Let's see how we can use this reflector. So we said we're going to use it to get the required route permissions. Okay, let's see what we can do here. So we have a few methods: get all and override, get all and merge. We're going to use get all and override. First of all, we need to pass in the key. So if you remember, the key we said is going to be this permissions right here. And if you don't want to have to keep writing it ourselves, let's just say export const permissions key. This is our metadata key, and we're going to call it permissions. Okay, and this is the same key that we are going to use here, okay, as our metadata key. And then here we need to pass in the targets that we want. So here we would say context dot, and we would need to specify the target. So in our case, we might have this permissions decorator on top of a controller or on top of a route handler. So both of these could be potential targets. So let's go ahead and say context dot get handler. This is a reference to the handler method that will be invoked next, so the route handler. And then we could say context dot get class, and if you take a look here, returns the type of the controller class which the current handler belongs to. So with this in place, we are now able to read the permissions decorator or the metadata, okay, the permissions needed for a specific controller or route, thanks to the reflector helper class from NestJs. I went ahead and added a log just to check that this reflector is working fine. And now let's apply this authorization guard on our controller here. Authorization guard. And here you need to know that whenever we're using use guard or use interceptors or whatever, and we pass in an array of different guards, NestJs is going to follow and respect the order that we set. So make sure to have authentication guard first before authorization guard, because orders matter. So now let's try and make a request to this endpoint to see what happens when we reach this authorization guard. And be aware, we still have not specified any roles or permissions for the user. This is just the permissions for the route, the permission required for that route. I'm gonna open Postman. I went ahead and already logged in with the user so that I can get a token, so that I can add this token. That way our authentication guard doesn't complain, okay? And now I'm just gonna add a log just to understand everything that's happening. I'm gonna say inside authentication guard here. It should be here. And I'm gonna add one for authorization guard. Let's open the logs and run our server. And now let's make a request. Cannot get, okay, this should be /products because we fixed this. As you can see, we got a response. And if you take a look at the logs, we got inside authentication guard first, and then we got inside authorization guard next, and we indeed got the required permissions that we set using our own custom permissions decorator right here. So we got an array of resource products, and then the actions, an array of just the read action. So using the reflector, we were able to get the correct metadata for the permissions required for this route. Amazing. Now let's go back to our roles module for a second. If you remember, we created a create role endpoint, which is going to take a new role. So we need to specify the role name and then the array of permissions. Okay, so let's go back to Postman. I created this payload. I'm gonna create a role called name, called admin, and then the permissions are going to be resource settings, and then we have actions read create. I'm also gonna go ahead and add another resource, permissions for another resource. So for example, we said we also have products. I'm just gonna add, let's say delete. Let's hit send. And as you can see, we have created a new role. If you go back to our database now, after refreshing, we can see that we now have a new document inside of our roles collection, which is name admin. And then in the permissions array, we have two different permission objects. The first one for the resource settings, we have read and create access. And then for the products resource, we have the delete action. Now let's assume that this user, John, with abc@gmail.com as an email, has this admin role. So I'm gonna take this ID for this role. This is the role ID. And then just like we said, our new schema now has a role ID here. So I'm gonna add this, which is going to be a object ID. Of course, you would have some logic in your code to assign the roles manually and so on, but just for this video, I'm gonna add it manually, of course. And now we know that this user, John, okay, has this role ID, which is the one for admin, and admin has the following permissions. The next step is to actually get the user permissions, so John's permissions inside of the authorization guard, so that we can compare it and check that every required permissions from the route handler that we got from the reflector helper class is contained, okay, inside of John's permissions. So inside of the admin role permission, since John has this admin role. So the next step inside of our authorization guard is to actually get this user's permission. So what we could do is, inside of our authentication service, for example, we could go ahead and create some method. For example, let's call it get user permissions. It is going to take the user ID, which is going to be a string. And inside of this auth service, we already have injected our user model. Of course, based on your architecture and your project, you might have a separate module for users and so on. But here, I'm gonna follow my example. So let's get the user first. Wait, this dot user model dot find by ID, and then we are going to specify the user ID. So what this does, basically, we're just getting this user. Now, after getting this user, we need to get the role ID and then access this roles collection to fetch the list of permissions so that we can make the comparison. So here, what we could do, for example, if not user, let's say throw bad request exception. And then in case we do have a user, we need to get the role object. So we could say await this dot, and here we could, for example, inject the role service here. And of course we would need to make the imports and all of that, so the role service. And of course now in auth module, import the roles module so that we can access the services. And here we need to make sure to export the role service so that we can use it whenever we import this roles module somewhere, just like we did here. And now here we need to call some method, for example, I believe get role by ID. So we could say user.role ID, and here we need to say .toString because we specified the argument as a string. However, in the database it's an object ID, so we can just simply say .toString. And then here what we could do is return role.permissions. So we can now call this getUserPermissions to get the user's permission or the permissions of the role that a user has. Just like we said, we have dynamic roles that we can create dynamically, and the permissions are well defined since we have the enums with some constant values for the actions and the resources. And now we need to make sure to call this getUserPermissions inside of our authorization guard. So let's go back to our authorization guard, and here to be able to call that we need to inject the authentication service. And what we can do now is get the user permissions, so we could say const user permissions equal await this dot auth service dot get user permissions, and then here we need to pass in the user ID, which we already have here. We already checked that we have it, and again we have it because inside of the authentication guard, after verifying the payload and the token, we are attaching the user ID from the token payload to the actual request before entering this authorization guard. And here we would have the user permissions, and we have the required route permissions, which I'm gonna call route permissions to make it simpler. And here it's whining because we are injecting the auth service. However, inside of the auth module, we're not even exporting this service, so we cannot use it yet. But this is gonna change now, and this should be fixed. Amazing. And now just to make sure that everything is working so far, what we could say is, let's say the route permissions are, and then this is going to be our route permissions. And let's also log the user's permissions that we just got. The user permissions are, and then let's log the user permissions that John has in our request. So if you open Postman now and go back to the endpoint that we're calling, where we are applying our permissions decorator and the guards, let's hit send, and let's take a look here. We can see that we got inside the authentication guard first, and then the authorization guard next, and then we can see that the route permissions are, okay, now here we got object. Basically it's the single permission that we have here, which is this one, which is resource products, and then action, which is just read. And then we can see that we also logged the user permissions that we got, which is the admin role permissions that John has, resource settings, actions read, create, and then the second resource products and actions delete, which is the same one that we have created here, and this is the same one that John has reference to. So actions read, create for settings and delete for products. So now inside of our authorization guard, we have all the context that we need. We have the permission of the user and we have the permissions of the route. So all we have to do is just make the comparison, and then if all the permissions that are required by the route are available for the user, then this user can actually access this route, so we return true. Else we would throw some error. Typically you throw forbidden exception, unlike unauthorized exception, because forbidden means 403, meaning that okay, you are authenticated but you do not have enough permissions, which is what authorization is all about. Making the comparison is very easy. Basically, since we have a permissions array, here this is an array, and we have a resource and actions, all we have to do is we can loop through the route permissions, and for every resource we need to check that this resource first exists for the user permissions, and then that every action that is required is also contained in the actions array for that resource for the user permission. If one of them is missing, we throw an error and we stop. If not, we keep going with our loop until we finish our resources and go through all of our actions. First of all, I wrapped this auth service or get user permission by a try catch block, because this might throw an error, bad request, and then I would catch it and then throw new forbidden exception. Now let's go ahead and do the loop and comparison. So let's start with the required route permissions. We need to loop through that. So let's say for route permission of route permissions, okay, we need to first ensure that the route permission dot resource is available for the user permission. So what we could say is user permission equal user permissions, okay, dot find. So we are going to search through the permissions to try and find one that has the same resource, okay, to make sure that this resource is available for that user. And here for route permissions we can specify the type as permission array, and now we could say dot resource. So we are going to try and match, okay, and match this resource, and then if we do not find a match, meaning the user permissions does not have an object for this section, meaning they don't have access to that section at all, then what we could do is, if not user permission, so we did not find it, we just throw a new forbidden exception, okay. Else it would mean that we have that section. The next step would be to make sure that we have all the necessary actions that are required in the route permissions. So doing that is pretty simple as well. Let's go ahead and, for example, name a variable all actions available equal, and now we need to loop through all the route permissions actions. So route permission dot actions every, okay, and now we need to make sure that every action inside the route permission is actually contained in the user permission of that section. So we already have the user permission section here, which is one single permission, which means resource and actions array. Because if you take a look, just to make sure that you're on the same page as me, we have the single permission entry now. So we have the resource that we are checking, and now we still need to check the actions array, that every single action inside of our route or required route permissions are available for that user. So here what we could do is, for every instance, we need to check, let's say, required action if user permission dot includes, and then here we pass in the required permission. So we are checking if the user permission for that specific section or that specific resource contains all the actions that are required by this route. Now if we don't get true, so basically dot every returns either true or false if all the different conditions are met. If not all of them are available, so we might have one action that is missing, for example, that's it, we don't have permission to this route, so we will throw new forbidden exception. So if you go ahead to Postman and hit send, we got forbidden. Let's take a look why. So basically the permission needed for this route is resource read. However, our admin role, if you take a look here, we have settings and we have products, okay. So for the products we have delete here. However, this route requires read. So let's say we had read instead of delete, okay, and let's try to make that call again, send. As you can see now, we got access to this resource. We did not get forbidden. I'm gonna go ahead and create a second role called superadmin, which has settings, action read create, and products, action create, read, and delete. I went ahead and modified the permissions that are needed for this route. So we now need read and create on the products resource and read on the settings resource. Now currently our user, which is an admin, and now of course if we refresh we have two different roles. Our user, which is an admin, has settings, read, and create. If you take a look here, we have read, so this is perfect. And for the products we only have read, however we need read and create. So now if I were to make a request, I should get forbidden. As you can see, forbidden, because we don't have enough permissions. However, if we had the super admin role, okay, which has all the necessary permission that we need for this specific route, so I'm gonna take this role ID here, update. Now if I were to make a request again, as you can see, we got accessed resource. So our authorization guard and our permissions are working perfectly. Our system is now secure. This video was a bit complex maybe, so let's go ahead and summarize everything. So we said we need a way to authorize users or to make sure that only specific users with a specific set of permissions are able to access some routes. For that, we could use roles and permissions. Now, some systems might have role-based authorization, where we just have some predefined roles, for example, admin, customer, user, that's it. Some others might have permissions attached to a user, where you have maybe resource and actions. And in our system, for example, we used both together. So we were able to create dynamic roles. And on these dynamic roles, admin, customer, or anything that we decide to create, we can specify a set of permissions that are predefined, since the resources are predefined and known beforehand, such as the sections that our system has. And of course, the list of actions are also predefined, normally CRUD operations. Of course, you can add some other actions depending on your use cases. Now, we said we might have different ways to store our permissions. Like, for example, we could have section name or resource, colon, and then, for example, create, and so on. We said this is an easy way, but it's not very scalable. We saw a second way, and then finally we said that this is one of the best ways. Maybe it covers 80%, 90% of the scenarios, of course, depending on the complexity of your systems, but I find this way to be pretty good. So we went ahead and created a schema. We defined a role schema to be as such. We have a name, and then we have an array of permissions, which looks like this. We have a resource, and then an array of actions, which are defined here in our enum. Now, the next step was to actually specify what permissions are needed or expected on which route. So we said that we can go ahead and create our own custom decorators, which is a function that takes some arguments and then returns some metadata. We said that we would need to specify a key and then the value, the key for our metadata. So we called it permissions in our case. And then the value would be whatever argument we pass in to our decorator. So to take an example, if you take a look at app controller, we are using our custom decorator here. Of course, we have the @ symbol and then permissions, and then we are passing in the permissions array. So this is the value of our metadata. Now we said to be able to actually access this metadata from the targets that could be a route handler or the target that could be the controller. So of course we could have actually specified this here. This permissions could have been specified here. To do that, what we could do is leverage the reflector helper class from NestJs, which is going to help us get the metadata values that we need. So we could say get all and override, or get, or whatever. We use get all and override so that if we have if we are using the permissions on top of the controller and then on top of the route handler, we would override with the new value. We also said that we would need to specify the targets here. Here we specified context.getHandler, so our route handler, and then context.getClass. Now if we had get, for example, we could have specified, let's say, context.getHandler only, meaning we would only read the permission decorator from the route handlers. If we had this, okay, this is a side note, this permission right here would not work. We would not get anything because it's on top of a controller. If we hit send now, as you can see, the permissions are undefined, and that's because we have this permission decorator on top of the controller. However, our target specified inside of this reflector is getHandler. So here we would need to say getClass and so on. But I prefer to actually have both targets, so I just use getAll and override. So this way, if you have the same permission set needed for all of your route handlers, you don't need to add the same piece of code or same piece of metadata everywhere. You could just add it on the controller level. And then if for one specific or two specific routes you need to override that, you could simply just add another one here. But again, you need to make sure that on the reflector class or instance, you are using this getAll and override method and then specifying both targets, the controller and the route handler. The next thing we did was we got the user permissions. So we use our auth service to go ahead, fetch our user, and then from our user object, we got the role ID and then called our role service to return our role, which contains the list of permissions that we need to loop through and make sure that it is contained in the required permissions for that route. Now, of course, there's one more thing that we could do here. For example, if route permissions was empty, so if we didn't have a route permission, if it was undefined, for example, we could just return true, meaning in case we just had a controller here, okay, and we were calling the authorization guard and the authentication guard, but we didn't have a permission decorator at all. So in that case, that would return undefined. So if it's undefined, any user can access it as long as they have a token. So as long as they pass this authentication guard check, okay, they would arrive here in the authorization. Since there's no route permissions, we would just keep going with the request. We give access. This is just another side note. That's pretty much it for this video, guys. If you have any questions, make sure to leave them down below. If this video was helpful, please make sure to leave a like, subscribe, and I will see you next time.